Hello, great people. Mr. New Love is here again. We are still dealing with Differential Calculus Series 2. The other one, we talked about average gradient. And now I know you know how to find average gradient. Today, we are going to look at how to find the limit if a function is given and you are told to find the limit. How are you going to find the limit? Last time we talked about the limit a little bit, where a number is approaching or where a height is approaching a certain value. So let's quickly look at these examples. For instance, if we are told to find a limit as h approaches 0, we must find this function 4h minus 4. What does it mean? It means when you see h, you substitute 0 because h is approaching 0. So here you are going to have 4h. The 4h is 4 times h. So it's going to be 4 times 0. Why 0? Because h is approaching 0. So 4 times 0 minus 4. So this is going to give us minus 4. It's so easy. Then let's look at question 2. We want to find the limit as h approaches 0. This function 5 over h. How are you going to do that? So it's going to be 5 over 0 because h is what? 0. And you know we can't divide by 0. So the limit will not exist. So the limit does not exist. Okay. Now the next one is going to be the limit as x approaches 2. You see that this time is x. So it means the function has a variable x. So the limit as x approaches 2, we are supposed to find this function minus 5x squared plus x minus 1. So when you see x, what are you supposed to substitute there? 2. So you have minus 5, 2 squared plus 2 minus 1. And if you simplify this, what are we going to get? Minus 19. Let's check with our calculator and see. So here I will have my minus 5 bracket 2 squared plus my 2 minus 1, and it gives us minus 19. Okay, now let's move on to the next one. So easy. Okay, now we are moving to the complex one. This one also, we have this expression. Say we should find the limit as x approaches negative 3. Now you have this expression. How are you going to do? Don't just substitute. Try and factorize this and simplify it before you substitute x as negative 3. So if you have this x squared minus 9, this is difference of 2 squares. We know that this is x squared minus 3 squared. So this is going to give us x minus 3, x plus 3. Difference of 2 squares over x plus 3. So this can cancel out. So we are going to have x minus 3 then you substitute. So if I substitute x as -3, I'm going to have -6. Are we together? Okay, let's continue. Okay, now we are going to look at, I will send you the examples. I will send you questions when I'm done. Now let's look at this. Using limits to find the gradient at a point. Remember, in our previous discussion, we talked about average gradient to be change in y over change in x. That is f of x1 minus f of x2 over x1 minus x2. Or if you interchange it to be f of x2 minus f of x1, this side is going to be x2 minus x1. All right, we did it in the last series. Now we want to use the limits to find the gradient at a point. When we're finding the average gradient, we didn't use the limits. We didn't include the limits because we're trying to find the average gradient. But we want the gradient at a point. So we know average gradient is this. So it's changing this y over changing x. That will help us to find the aggregate gradient of 2 points, like this point and this point. Okay, now let's move on. Now if we take, or we let the first x coordinate and assume it to be b units away, then the second x coordinate will be x plus h. So our average gradient, we are going to have x plus h minus x over x minus x plus h. All right, so here we are going to have x minus x, which will be 0, which will give us h. So here the average gradient is going to be at a point. We call it a first differential, or differential from the first principle. This is the formula that we'll be using. Don't be scared. In your exams, the formula will be given to us. They are not going to ask you to prove it. We'll only learn how to use it. All right. Okay, so here now we are going to have it's like this is x2 minus x1, which our x2 we call it x plus h, then minus f of x divided by our h, the change in x2 minus x1. So this formula will be given to us. You only learn how to use it. So here our average gradient will be this. As the distance between the two values of x becomes smaller, that is when it approaches 0, the smaller, so that the second value of x gets closer and closer to the first value. So when it gets closer and closer, there's no distance. It means it approaches 0. So that the distance between the 2 points h becomes very small and approaches 0. We will find the limit as h tends to 0. That is, the distance becomes 0, or it approaches what? 0. The average gradient will change. Call it instantaneous gradient. or gradient at a point. Another term is what? Derivative. So when h approaches 0, that is when the distance approaches 0, or the limit h approaches 0, we find the derivative. The name changes from average gradient to what? Instantaneous gradient. We don't normally use this. We use the derivative, or we use this one, the first principle. All right. So anytime you are told to find an expression in this form from the first principle, we use this formula. We'll be working more questions on this using this formula from the first principle. Okay. And the formula will be found in your formula sheet, grade 12. Okay, so we want to find the differentiation from the first principle. So this is the formula. You write in your book nicely. Anytime you are told to answer a question from the first principle or find a derivative from the first principle, you first write the formula. So like this question, they want us to find f prime, or the derivative from the first principle. In other words, f prime of this one, f of x is equal to 3 from the first principle. The first thing you need to do is you find f x plus h. We'll do more examples. You know, here f of x means f of a domain is equal to 3. Remember, this 3 is constant, so it means f x plus h will also be 3. It's not going to change because we don't have any x value anywhere. So the constant, so that a constant so does not change. The constant remain as it is. Now, so this is the formula which will be given to us. You write the formula, then you substitute fx plus h. What is fx plus h? Is 3 minus fx plus h is 3 minus f of x, which is also 3, divided by h. You know, as h approaches 0, that will be 0. So 0 over h, let's not take the limit. 0 over any number is what? 0. Remember, if you take the limits now, it's going to be 0 over 0. We can't divide by 0. Né? So here 0 over h becomes 0 direct. So anytime you find the first derivative of a constant is 0. Okay, let's look at this, the next one. You try this one. First derivative of this. Try it and let's see. Let me just give you a few minutes to try before I continue. Just giving you a few minutes. I hope you are winning. You first find x plus h. You use the formula. It will be given to you. That's why I've written it for you. What are you supposed to put here? Yeah. Few minutes. Okay, let's go through. Now, since this one is a constant, it will still be 5. Then we know x plus h is still going to be 5. So it's going to be 5 for this x plus h minus f of x is 5 over h. So 5 minus 5 is 0 over h, which will give you 0, like that one. So anytime you have a constant, if f of x is equal to 6, it's still going to be 0, like that. Okay, now let's look at another question where it's not a